Let's solve LeetCode 11 container with most water. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height at I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So let's say the input is given as height equals to this array. This array is just a list of integers and the output here is 49. How? Well, let's again read the question. There are n vertical lines. So let's say in our case, there's 3, 6, 9 vertical lines drawn such that the two endpoints of some random ith line, let's say the fourth line, are I, 0 and I, which is 4, the value at position 4. For example, this is 0, right? I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, and I equals 4. So what this is I, 0 and I, 4. What is going to be the max amount of water this container can store? You might think that it's just this, right? So it would contain this amount of water, and that's not correct. It can only contain this amount of water. That's because if you have a container, one line is bigger than the other, you can only store the water that's present in the minimum of these two things, correct? And the container cannot be slant, so you cannot have water stored like this somehow. What you need to have is container that's stored like this. So water is up till here. So the answer would actually be 1, because that's the y-axis, and the x-axis is going to be the difference between this and this. So if this was 0 and this was 4, it's going to be 4 minus 0 into 1, which is 4. But now we need to do the maximum of all of the lines that are given. And the correct answer here is 49. How? Because if you take I is equal to 1 and I is equal to 8, which is the very last one, what we'll have is something like 7 multiplied by, I believe this is 7 as well. So we'll have 7 into 7, which is 49, and that's the maximum. Now you might say that, hey, there's another bar that's bigger than this guy. So how is the maximum area between these two things? Shouldn't it be between these two things? We can calculate. So the minimum of these two lines is 8 in the vertical direction, and the difference between their indexes is, let's say, 0, 1. So this is 1, and then we have 2, 3, 4, 5, 6. So it's going to be 6 minus 1, which is 5. And then you multiply it with 8, which is just 8 into 5, which is 40. And 40 is not greater than 49. So just because the line is the maximum doesn't mean it can store the max amount of water. We also need to see in the horizontal direction. If you just look at the height of the line, you're just looking in one direction, vertical direction, but in area, you have 2 dimensions. So that's what we're solving for. Now, how do we solve this thing? I'm just going to copy this image and move it over to the drawing board. It will help us out. And now let's figure it out. The very first approach that comes to my mind is we just start from this part, right? So I take this guy, I keep this as a constant, and then I go over all of the elements trying to figure out what the maximum length over here is going to be. So let's say my k is this, my I is this in the very first iteration. So I check what is the height over here. Well, that's just going to be 1 because, this is 1. The minimum of these two lines, and then you have the index 0 and then index 1. So 1 minus 0 is 1, the height is 1, so the area is 1. So till now we have max length as 2. Then I do that with this. So we have this thing over here, this area that we can get, which is equal to something like this. So you have 0, 1 and 2, right? So the difference here is 2 multiplied by 1, which is equal to 2. So the max length we have now is 2. Okay. After that, we go till here and then it will be 3, then 4, then 5, and so on. So after the n, we'll have max length as 8, correct? Because this would be 8, this is 0, 8 minus 0 multiplied by 1, which is the vertical direction, you have the max length as 8. Now, the next thing we will do is change this constant, because as we know, the value that has the highest area, so the highest area value, one of the first lines is k equals index 1. So I'll have to change this k, and actually I'll have to change this for every single one of them, because I don't know where my maximum value is going to come out. So I'll have to test it everywhere else. And after keeping k constant at each bar, I have to check for the rest of the values as well. And that would give us a time complexity of O of n square. Now, obviously we don't want a time complexity of O of n square. We want a time complexity of O of n. The reason I think we can do it better is because I only need to go over this array once. I don't need to go over this array twice. If I can go over once, I will get to know the maximum area. So how can I do that? Let's see. If we use our brains, how are we going to get the maximum area in any case? Like, what's the most ideal scenario where we can get the maximum area? We can either prioritize the height. So what we'll have to do is find out the maximum of height, and then for that one, I'll have to keep checking that, hey, this is the maximum bar that I could find. Now let's keep this as a constant, and I can find other elements that have a maximum area, but that is not guaranteed to give me the correct answer, as we have already discussed. What if I start from the very ends? What if I prioritize basically the horizontal length? So what I can do is just start from here. So my left pointer is going to be on the very first index. My right pointer is going to be at the very last index. And then what I can do is find the minimum of the value at left and the value at R, and then calculate its area. Okay. So that's going to be my max area. Well, technically max area is going to be whatever the max of max area is with respect to the current area that we find out over here. But initially we are going to initialize max area to 0. So the max of 0 comma whatever this line is, whatever this area is going to be, well, the max area, correct? But we know that. So we found out that the max area as of now is 8. How do we change this number? Well, what I can do is just check, hey, is the value at left greater than the value at right? If it is, then I want to move R by 1. That means I want to decrement R by 1. That's because I want to find out the bigger element. But in our case, the truth is that left is smaller than right. So what we'll do is take this left out of here and move to the next index. The reason we'll move to next index is because as soon as we find a value that is greater than R, so that means if left is smaller than R, we'll move by 1 because we are in search for a bigger value, because a bigger value will mean that we have a greater area, because to get a maximum area, I have to prioritize the vertical length. Let's call it Y. So the Y axis, and then I have to prioritize the horizontal distance, which is the X direction. So I've prioritized the X direction by just finding out the left and the right components, which is the very ends of this graph or this chart. After that, what I do is just check that, hey, I want to prioritize the vertical direction now, because in the horizontal direction, I've tried to prioritize it. I'm starting from the very ends. So what I'll do is now prioritize for the length of the bar. So as soon as I do that, I'll check, hey, is L smaller than R? Yes, it is. So we'll move this L ahead so that we possibly go to a bigger value. It's not always guaranteed to be a bigger value because the array is not sorted, but it can be a bigger value, and that's what we are looking for. After that, what we can do is, well, the left has changed. I'll again calculate the area, And now the area is going to be, well, 7, which is correct. This is the 7th, the minimum of this guy and this guy, multiplied by the horizontal direction, which is also 7, which gives us 49. But till now, we are not sure that it's going to be the max area. So what we'll have to do is move forward now. Now, how do I move forward over here? I'll again check if L is less than R. And no, left is not less than R. In reality, R is less than L. And whenever, by the way, I say L and R, it basically means that the num or height at L is less than num at R. Okay, I'm not talking about the pointer indexes value. I'm talking about the actual bar value. So cool, 7 is smaller than 8. So what we'll do is go over here. And when we go over here, we notice that, hey, my height is decreased. So that's not going to give us a bigger value. So here we'll probably be getting something like, I'm not sure what this is. It's probably 3, but they've not made the graph correctly, I guess. So let's consider this as 3. And well, we'll also take the 3 here. And then this is equal to 1. And I think this is index 6. So, or probably index 7. I don't know. So 7 minus 1 is 6. And then we do 6 into 3, which is 18. 18 is nowhere close to 49, which is the max area. So we'll move ahead again. Now, how do we move ahead? Again, we'll check. L is less than R. No, R is less than L. The right value is less than L. So what I'll do is take this and go over here. As soon as I go over here, both of them are equal. So I'll just calculate again. We've already calculated that the value here was 40. So yeah, it's not max value. We can move ahead. Now, which one of these pointers will move ahead? Either one, it doesn't matter. So we'll just move to, let's say the R1 can move, and then we calculate again. After that, again R will move, again R will move, and then again R will move. Because every time R is less than L. So this is our solution. The time complexity of this becomes O of n because only the right or the left pointer move only once. So we are only visiting every element of the array once. This is why it's O of n, and the space complexity will become O of 1 because we are only using the left pointer, which points to an index, which is a number, right pointer, again an integer, and then we just have to store the maximum area, and that is O of 1 as well. So let's code it up. So we have a left and a right pointer, which is equal to 0, comma, the length of height minus 1. So we are starting from the very beginning till the very end. Then we have while L is less than R. So while this is on, we'll keep going on. And then what I want to do is check that, hey, what is the area over here? So I'll find out that the area is equal to the minimum. Let me just actually write it down in more variables. So we have y. So the y axis, the vertical direction, what is that going to be? It's going to be the minimum between the height at L and the minimum with the height at R. So the minimum of height at L and height at R. So that gives me the vertical direction. The horizontal direction, X, is already given to us, and that is going to be the difference between R and L, correct? So we calculated that previously. If this was index 8 and this was index 0, we calculated 8 minus 0. Cool. So now that's done, we can find out the area, which is equal to x into y. That's how an area of rectangle goes. After that, we can check that, hey, we want to update the L and R pointers because we need either one of them to move ahead or behind. How are we going to check that? If height at L is less than height at R. So if that is the case, that means we are at this situation, L and R. L is less than R, so L needs to move forward in order to get a bigger value. So we'll just maximize L now. And if the opposite is true, so that means height at R is less than height at L, or it is equal to height at L, in that case, I'll just do this. Even if you do this condition, height at L is less than equal to height at R, it won't matter. But yeah, either ways, it's fine. And we also need to store the maximum area. So let me create a variable. Max area is equal to 0 initially, because, the maximum area can only be 0 because we are given that the area can't be negative, because we are actually talking about a real container in the real world, and a real container cannot have negative values unless you're talking to a physicist. So yeah. So we now have max area equal to the max of max area comma area. And that's basically it. At every point, we just calculate the maximum value, and then we will just return the max area after we're done going through the entire array. So let's run it and see if that works out. Yep, it does. Let's submit. And that works out as well. Now, one thing that you need to keep in mind here is that the initial solution that we had was O of n squared. And the reason I went to a solution of O of n was that I went to the two-pointer approach. So that is a very useful thing to keep in mind. If I would have done the O of n square approach, I would just keep this as a constant, traverse rest of the values, then keep this as a constant, traverse rest of the values, and so on. But with the two-pointer approach, it's very smart because my left pointer is here, right pointer is here. Initially, we are increasing maximum distance horizontally, and then we are optimizing for the longest height, so we are maximizing for vertical after that. So yeah, this is the solution.